In today's lesson, we're going to have a look at calculating bearings using our angle facts. This could be angles on a straight line, angles at a point, or any of the rules for our angles in parallel lines. We also need to remember the definition of a bearing. A bearing is simply an angle measured clockwise from the north point, and we always write it with 3 figures. In the 2 examples below, we're asked to work out the bearings from A to B and also from B to A. There are many different ways that we can work out these answers using our angle facts, but I'm going to show you 2 so you can look at the different ways of approaching the problems. Now, the first thing we need to recognise is that every single north line is going to be pointing in the same direction, and because they run alongside each other, this means that they're parallel to each other in the question. So, looking at our first example, it's asking us to work out the bearing from A to B. So we go to point A because that's where we're going from, draw our north line going up, which we have already, and measure the angle clockwise round until we hit the line which is connecting to point B. We can work this angle out because angles at a point all add up to 360 degrees. So we can do 360 subtract 237 to work out what that missing angle is. We need to borrow from the 6, and we get 10 take away 7 is 3, 5 take away 3 is 2, and 3 take away 2 is 1, meaning this missing angle just here is 123 degrees. That also means for part A, the bearing from A to B is also 123 degrees. For part B, I'm asked to find the bearing from B to A. So thinking about what that angle is, I go to point B because that's where I'm going from and have my north line going up. I measure clockwise around until I hit the line that's joining point A, so we want this angle on the outside just here. Now, to help us work out what that angle is, I'm first going to work out this angle just here. This angle is co-interior to this angle above it. That means that 123 and this missing angle that I've just labelled add up to 180 degrees. I can therefore do 180 subtract 123 to find out what it is. I need to start off by borrowing. 10 take away 3 is 7, 7 take away 2 is 5, and 1 take away 1 is 0. So I know that this missing angle just here is 57 degrees. Again, I can use the fact that angles at a point add up to 360 to subtract 57 and find the missing angle, which is the bearing from B to A. So I'm going to do 360 subtract 57. I need to borrow again, so I get 10 take away 7, which is 3, 5 take away 5, which is 0, and 3 take away nothing, which is 3. That therefore means that the angle on the outside is 303 degrees, and that also means that the bearing from B to A is also 303 degrees. In this next example, we're given a different angle to start with. Because of this, it's probably easier to work out part B, which is the bearing from B to A first. In fact, the angle that we're given is that, because if we go to point B, draw our north line going up and measure clockwise around until we hit A, it gives us this angle that we're given. So we can start off by saying that the answer to B is 314 degrees. I can now work out part A, which is the bearing from A to B, by reversing the process of what I did last time in the previous question. I'm going to begin this by finding this missing angle just here. I can work it out because I know angles at a point add up to 360 degrees, so I can do 360 take away 314 to work out what it is. I need to borrow, so I get 10 take away 4, which is 6, 5 take away 1, which is 4, and 3 take away 3, which is 0. That gives us a missing angle of 46 degrees. That's useful because I can now use the fact that this angle and the angle 46 are co-interior, and that means that they add up to 180 degrees. I can use this fact because both the north lines that I'm given from the points are parallel to each other. So I need to do 180, subtract 46, and that will tell me what the angle is. I need to borrow. 10 take away 6 is 4, 7 take away 4 is 3, and 1 take away nothing is 1. That means that the missing angle is 134 degrees. Now, if you think about what we wanted to find, we wanted the bearing from A to B, and that's exactly what we've just worked out. We're going from point A, so we've got our north line coming out of it. We measure clockwise around until we hit the line which is joining to point B, and that is the angle 134. So I can say that for part A, the bearing is 134 degrees. An alternative way of thinking about these problems is to use our angles on a straight line facts by extending the line that we're given between A and B out. We can work out in the first problem, just like before, that the answer to part A, the bearing from A to B, is 123 degrees. That's because angles around a point add up to 360 degrees. This time, to work out the bearing from B to A, I'm simply going to extend the line between A and B out and use the fact that corresponding angles are equal to say that this angle here is also going to be 123 degrees. Because the dotted line is simply an extension of AB, I know that this part underneath must be 180 degrees, and I can therefore use that to work out the bearing from B to A. If I take 123 and I add 180 to it, I get 3 add 0, which is 3, 2 add 8, which is 10, 1, 1, and the 1 that's carried over gives me 3. So it tells me that my total bearing for part B is 303 degrees. That's the same as what we got when we did it last time. Just like previously, I know straight away that the bearing from B to A is going to be 314. Just like we did before, I can extend the line between A and B out, and I can take 180 degrees, which is this bottom bit, away from 314 to work out this angle just here. So I've got 314, subtract 180, 4 take away 0 is 4. For the next part I need to borrow, and I get 11 take away 8, which is 3. And lastly 2 take away 1 is 1, meaning this missing angle here is 134 degrees. As with the last example, we know that corresponding angles are equal, so this angle over here must also equal 134 degrees, meaning that the bearing from A to B for part A is 134. Again, that is the same answer that we got when we did it previously. I'd now like you to have a go at the following worksheet. It's attached to Show My Homework in the Resources to Help You section, so you can either download it, print it off and write your answers onto the sheet, or you can work directly into your maths books. I would like everyone to answer the questions from 1 to 5, which is the first 2 pages of the worksheet. There is, however, an extension for people that want a bit of a challenge, which is question 6 at the very end. Once you've finished this, I'd like you to download the answers page from the Resources to Help You section and check your answers. If there's anything that you didn't get right, try and correct it yourself, and if you're unsure, leave me a comment on Show My Homework. Once you've done all this, take a photo of your work and upload it to Show My Homework so I can see what you've been up to. Good luck. If you are struggling to complete some of the work from today's lesson, then please do not hesitate to get in touch via comment on Show My Homework. I'll try to make myself as available as possible and get a reply to you as quickly as I can. If the issue requires a little bit more input from myself, I might ask to arrange a time to meet on Teams where I can give you some personalised help with that specific problem.